Today we're going to go over how to factor some trinomials where the first term is 1. Sometimes these are perfect square trinomials, and we'll go over that very specific style here in a minute. But this chart factoring, I'm just going to come up with an example. What do we mean by chart factoring? That's a good question. So as soon as I can get this to work. Okay. You'll also see where we talk about perfect square trinomials. That's a very specific type of a trinomial where the first term is 1. We'll go through that in a minute. But in order to understand what we mean by this chart, I wanted to come up with an example. So let's say we have x squared minus 2x minus 35. You look at your last term, and we're trying to multiply to get to that term. This is where you generate your choices. So you go to the end first. So we're going to multiply to get to 35. Then how you know you pick the correct answers is that it's going to either add or subtract to get to the middle. So if we think about some factors of 35, 1 times 35. So we're supposed to add or subtract to get to a negative 2. So if we add these, we get 36. And if we subtract them, we get 34. Or negative 34, depending on the order. That's clearly not a 2. Some other factors of 35, just kind of go through them. You can use your calculator if you can't come up with some. But like 2, 3, 4, that doesn't work. 5 works. This is 5 times 7. If we add those 5 and 7, we get 12. But if we think about it being 5 minus 7, if we add these, then we can get a negative 2. So these are going to be the factors right here, 5 and negative 7. So you always make 2 sets of parentheses. In order to get to the first term, this x squared, we have to split that up evenly. That would be x times x. We already know what the numbers are. One's a positive 5 and the other is a minus 7. And then it doesn't matter which one goes first or second. Then you can see, if we were to check this, we get x squared. Outside is a negative 7x. Inside is a plus 5x. And then 5 times negative 7 is a negative 35. So we go to add this up, we get x squared minus 2x minus 35. So it does in fact work. So let's go through a few of these. Now this perfect square trinomial checklist at the top, basically they're asking you to go through and take a look. If the first term and the third term are perfect squares, you might have a perfect square trinomial. So if we think about the square root of x squared, that's an x, and if we think about the square root of 49, that's 7. Then what they're saying right here is if you multiply 7 times x and then multiply that times 2, if that's your middle term, then it is a perfect square trinomial. This doesn't really matter. We can still do this in the other way. This is just some extra details if you're looking for those extra details. But basically, we're trying to multiply to get to 49 and add or subtract to get to 14. So like 1 times 49 isn't going to work, but 7 times 7 will, because 7 plus 7 is 14. So we already know that it's going to be a positive 7 and a positive 7. In order to get to x squared in the beginning, it's x times x plus 7 plus 7. Please, 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 please don't forget about greatest common factor. You can see here that we actually have one. They have a greatest common factor. They have a 2 in common, so we have to take a 2 out. So we're left with x squared minus 2x minus 48. Now 48 is not a perfect square. I'm going to move my answer down here. So we think about this table or this chart. We're trying to multiply to get to 48 and either add or subtract to get to a negative 2. I call it add or subtract. It just depends on what you think of it as. So 1 times 48. Nope, that's going to be a 49 or a 50. 2 times 24. That's a 26 or a 22. 3 times 16. That's going to give us 19 if we add, and 13 if we subtract. 4 times 12. Nope. 16 and 8. I thought we were getting close. How about 6 times 8? There we go. If we make this -8 plus 6, then we'll get a -2. And so those are our numbers. That'll be perfect. So this 2 sticks around and does not go anywhere. And then we have x and x. And we know the numbers are -8 and +6. So if you do all their thinking beforehand, the answers work out pretty well. Now, when there's a number in the front, check for the perfect square trinomial. Like the first thing you should check is there a square root for 16? And there in fact is. Is there a square root for 1? Yes. Is there a square root for x squared? Yes. So I'm going to try that. The square root of 16 is 4x, and that would go here and here. The square root of 1 is 1. And if you take 4x times 1 and then multiply that by 2, just like this little part tells you, then that does turn into 8x. So we know that this works. Another way you can make sure is you could check this. Outside we get 4x. Inside we get another 4x. 4x plus 4x is 8x, and it's exactly what we're looking for. Now here's kind of a tricky one, because we know the square root of x squared is x, and we know the square root of 36 is 6, but check the middle term. Is 6 times x times 2, well, that's a 12x, so that's not 13. So 6 times 6 is probably not going to work here. So we're trying to multiply to get to 36 and either add or subtract, probably add to get to -13. So we have 1 times 36. That's 37 or 35. 2 times 18. That is 20 or 16. Oop. 3 times 12. Nope, that's 15 or 9. Oh, 4 times 9. There we go. So if we make it -4 plus a -9, that'll give us -13. So we're going to split up the x squareds, and now we know we're going to use -4, -9. Now you might be able to do this without the chart. So think two numbers that when you multiply you get 10, and if you add or subtract them you get 7. Well, 10 times 1 isn't going to work. 2 times 5, and both are negative. So if you can do this in your head, then do it. There are sometimes it's just easier because there's less choices, and you might find that some of these you really can do without a lot of extra work. So if you don't need the chart, don't make the chart. But then don't say, I couldn't figure this out, when you haven't really tried every single solitary factor. So we know this is going to be x and x. Choices to get to 12. Remember, you start at the end. 1 times 12, not going to give you 8. 2 times 6 will. And if we make them both negative, right, -2 plus -6 will be -8. Sometimes you get lucky like that and you guess right first. Now you might already know this. Remember, we start with things that multiply to give you 15. We know this is x and x. So multiply to get to 15. 1 times 15. No. Add or subtract to get to -2. That's not happening. And then 3 times 5. So we know that if it's a -3, a -5 and a +3, that gives you -2 when you add. So that those exact same numbers go inside the parentheses. So the perfect square trinomial doesn't really happen very, very often. It's not something you have to really pay attention to because all of these can be factored the same way.